Okay, this is integrated 1. We're going to do problem number 7-7. And it says, are the two triangles at right congruent? Make a sketch of both triangles, then determine all of the angle measures and all of the side lengths. If they are congruent, describe a sequence of rigid transformations that maps one onto the other. Note the triangles are not drawn to scale. So I'm not really in love with how they're having you sketch these on your paper, because they're not drawn to scale, but you can see that this side and this side are supposed to be the same length, right? And so I'm going to just kind of just draw them, just showing their orientation, you know, the way that they're facing, and then I'm going to label them. This is 69.39, this is 117, this is 44, this is a hypotenuse, this is 125, and this is... So who has an idea? It asks us, are they congruent? Does anybody have any thoughts on that?
Yes.
What do you have, Cody?
No, I said yes, they are congruent.
Yes, they are. Sandy?
The one where you find the length of the sides.
Uh-huh.
I forgot what it's called.
Pythagorean theorem?
Yeah, that one. A squared is B squared equals C squared.
Mm-hmm. So you can go 44 squared plus 117 squared and see if it equals 125, right? So this is, I'm going to write Pythagorean theorem. Because I had several students in class that have come, you know, some of them came from other schools, but they didn't remember this theorem. That's a pretty big deal, the Pythagorean theorem.
Question.
Yes.
It's like in Pythagorean theorem, C is always the longest side, right?
Yes, it's always the longest side. It's the hypotenuse. Yep. Okay, and then if I add those together, I get this big number. And then I'm not done yet. It's not really that big of a side. That'd be a huge side, right? I have to square root both sides to undo the squaring that happens right here. I know. So I've already got that in my calculator, that number. So I'm just going to push my square root button. I hope it'll work. And I got 125. Now that tells me that, and I'll write it in a different color, that tells me that this side right here is 125. And when I look at this triangle, its hypotenuse is 125. So that is confirming Cody's suspicion that they're congruent. Is there anything else I can do to prove beyond doubt that they're congruent? Or is that enough? Huh?
Find all the angles?
Find all the angles, good. So I know that the three angles in any triangle are going to add up to how much?
180.
180. So I can just go 180 minus the 90 minus the 69.39, and then I can get this number, 20.61, and 20.61 is the small angle right here, and it's also the one I just found right here. Okay, so if I have angle, 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 that means the triangles are definitely similar. They have the same shape, and now that I have the side lengths are equal, Pythagorean theorem proves it. I've done proved it. I've done proven it. So now what?
You have to
describe a sequence of rigid transformations. So I can, you know, you probably don't need to use this paper to do this, but I think it's going to be a rotation and a translation. Like, I feel as though I would just, oh, you can't see it. I feel like I could just take it and slide it around. Rotate it around.
Wait, so does that, like, since they're different sizes, does that mean they're dilated?
They're not different sizes, they're the same size. See? Because we
Oh,
proved all that.
scale.
Yeah, they're not drawn to scale, I know. But you're right, if they were different sizes, we would say that a dilation occurred. But, so what I had to do to get this one to map onto the other one is I had to do like a turning. And I know Rocco brought up something, if I rotated it around the right point, I actually wouldn't have to do any translating to it. So as long as you say something about rotation, you could say rotation and translation if you want to, if that's how you're thinking of it, but this is going to be correct if you have the word rotation written down. And let's check what your answer book. Your answer book says, translation and rotation. So, but it can be argued that you could actually find a point to rotate it about that where you wouldn't have to translate. There we go. Okay, so let's end this video.